Okay, good morning, everyone. Welcome to the last day of PDC. I hope that everyone's had a great time attending all their sessions. Sorry? Okay. Can everyone hear me? Anyways, well, welcome to the last day of PDC. I'm really excited to be able to talk to you about Silverlight 2's control model now. My name is Karen Corby, and I'm a program manager on the Silverlight team. Now, because it is the last day of the conference, I hope that you would indulge me a little bit, because I want to kick things off with a bit of a metaphysical question, which is, if you could be any of the buttons up on this screen, which button would you be? I know, deep thoughts, deep thoughts. Well, I asked myself this same question, and after staring at these buttons for a little while, it hit me, you know what, I don't want to be any of those buttons. I don't want to be some boring square button. What I want to be is squiggly and bright and red and shiny. And you might be asking yourself, okay, what's your point? But my meta point of this little metaphysical exercise is that in Silverlight 2, it's really important for us to give you the tools to be able to just lightly customize the looks of your buttons. But it's even more important for us to allow you to take any control that you get from a third-party vendor, from the Silverlight toolkit up on the web, or even from the core runtime, and allow you to take that button and make it look and feel and interact exactly the way you want it. And that's really important because I know that you've spent a lot of money and a lot of time and a lot of resources thinking about how you can brand your site on the web and how that branding is important for both attracting and retaining customers. And one of the key, secrets of having a strong brand image on the web is to be able to make sure that that branding permeates every aspect of your site. And that includes making sure that all the controls that you put on your page look like and interact like and feel like the brand image of your company that you're trying to sell. So with that, today that is our goal, to show you how you can kind of customize deeply the controls in Silverlight 2. We'll start out with a brief overview of the Silverlight 2 control model to make sure that everyone's familiar with the basics, which means that we'll start out with quite a few slides in the beginning. Then we'll dig straight into skinning in Silverlight and talk about how you can build up a skinnable control and how you can use something called the parts and states model to make building those controls easier and better. And finally, we'll talk about Silverlight and WPF and how those two control models really are the same and converging even further. Okay, so the key points of the Silverlight 2 control model, just at the highest level, are that there's two types of controls that you can build. There are user controls and custom controls, and we'll talk about them very briefly. And then we'll talk about the different ways that you can customize an existing control, and that is through skinning and through styling. User control in Silverlight 2 will be very familiar to you if you are already familiar with ASP.NET or WPF. User controls are great ways to very quickly bundle together some logic and some visuals in a very tightly coupled way. This is great for decomposition. So if you're trying to take your app and just break it into smaller pieces, for better code development, parallel development, code management, and also something that we like to call cheesy reuse, which is the ability to very quickly build up a control and then just use it multiple times throughout your application. So that's user control, and it's very useful. But there are cases where you don't want that tight coupling between the visuals and the logic. You actually want a strong separation between the code and the XAML. And you do that in Silverlight 2 with custom controls. And the goal here really is to enable a developer to create a piece of modularized logic that's independent from the visual look, which means that later designers can come in and change the visual look of that control without needing access to or needing to modify the code directly. So that's custom control. Now, if you have one of these custom controls, there's two different ways for a designer to change the look of that control. You have styling and you have skinning. In styling, for those of you who play a lot on the web and are familiar with CSS and HTML, or even style within WPF, the scenarios around property bag styling should feel familiar. It's a way for you to very easily tweak the minor visual characteristics of a control. So maybe changing the background property or changing the font size. So up here you can see a little bit of XAML, which shows off a style element in Silverlight 2. You can see that inside of my grid.resources, I have a style resource. That style resource is for a button. You can tell that by the target type. And I've also given this style resource a key, which is button style. Then inside of the style, I have literally a property bag. So I have a series of setters which set individual properties to specific values. So here I'm setting the foreground property to gray. Similarly, I'm setting the background property to purple, and so on. Now, the way I use this style is through something called a static resource reference. So I'm taking my button down there, and I'm setting the style property to that style resource that I just defined using the static resource syntax. And that very briefly is styling in Silverlight 2. On the other end of the spectrum is, of course, skinning. Skinning is a way for you to, instead of making minor characteristics changes on your control, to actually completely replace the look of your control. So here I'm doing that with something called a control template. Inside of my grid.resources, this time instead of defining a style resource, I'm defining a control template. This control template is also for a button. You can tell that by the target type, and I've also given it a key. Then inside of that control template, I've put all the visuals that I want to define my control. So I have a grid and a path and a content presenter. To hook up that control template to my button, I, very similar to before, set the template property, this time using a static resource reference to that control template that I just defined. The last part here is you'll notice on this button that I've also set the background property. I've set it to this gradient brush. And I want the control template to respect the background property that I've set on the control. And the way you do this is with something called a template binding. So within the control template, I'm setting the past fill property to be template bound to the background property of the button. And that way the control template is able to pick up that radial gradient brush that I set as the button's background. Okay, so that at the very highest level are kind of the building blocks of the Silverlight 2 control model. User control, custom control, styling, and skinning. And with that, I want to dig straight into the kind of the main part of this talk, which is skinning. And how do you build up a skinnable control? How do you build a custom control from scratch? At which point I will also quite literally step up onto my soapbox. Okay. So here is my basic custom control demo. I've got a snippet manager that I'm going to use periodically over here just to make sure that I don't forget anything. So inside of my solution over here, you can see I have a normal kind of Silverlight application, but I've also added a control library. And the first thing that we'll do is add a control. So I will add a new class. We're going to call this weather control. And then make this derived from control. Now our weather control is going to have a couple different properties. The first one will be the temperature property. And at this point, I want to call out that if you add a property to a control, if you want that property to be able to be stylable, to play with data binding or template binding, it needs to be in Silverlight 2 something called a dependency property. And the way you define that is by literally defining a public static dependency property. We'll call it temperature property, because that's the naming convention. And I will register it using the dependency property register static method, giving it the name temperature, the type of string, giving it the owner class, which is weather control. And then I don't actually want to provide it any metadata at this point, so I'm just going to pass in null. So that's our temperature property. And I'm going to drag in two more properties that are very similar to that. We have a condition property, and we also have a condition description property. This condition property is of type condition, and you can see right here that my condition has one enum value right now, which is sunny, because I'm optimistic. Anyways, one thing I forgot up here is to call out that when I define a property and I back it by a dependency property, I actually need to hook up at these getters and setters to interact with that dependency property. So here, I'm going to use the helper get value and pass it the temperature property that I just defined. And similarly, in the setter, I'll use the set value helper. Okay. And that is the basic shell of our custom control. Now we can go to page.xaml and add this control to our page in Silverlight. The first thing we need to do is add a custom namespace. And what this custom namespace does is it allows the parser, as it's parsing the XAML, to know where to find the control that we're about to use. So here I can drag in a weather control into my page. You can see it's using that prefix, and it's setting the temperature, condition, and condition description properties. And I will hit Control F5 and stun you with an empty demo, which I actually did on purpose. Thank you, thank you. And that's because by default, remember that control in Silverlight is really just logic. We haven't at this point defined what that control is going to look like by default. And so without doing that, this is exactly what our control will be. It'll be nothing. So let's go ahead and give our control a default look. The way we do this is we go into the assembly where our control is defined. We go into the themes folder and add a new file called generic.xaml. This generic.xaml needs to be included in my assembly in a special way. I don't want it to be compiled as a regular Silverlight page. I need it to be a resource. And I'll remove this custom build task too. Okay, so we have our generic.xaml page. The next thing we need to do is set it up. So inside of generic.xaml, I copied in a resource dictionary. Generic.xaml is a resource dictionary just like grid.resources is a resource dictionary or app.resources is a resource dictionary. It's a place for me to define XAML assets. But more specifically, it's a place for me to define the built-in styles for a particular control. So let's define the built-in style for a weather control. I'm going to drop in here and add in another custom namespace. And also drop in a built-in style. So the first thing that you might notice about this style, it looks like a normal style element, except for the fact that it doesn't have a key. And the reason it doesn't have a key is within generic.xaml, if you don't put a key, we'll automatically use the target type in order to look up that style. Okay, so we've set the font size within this built-in style to be 16, but the more important thing we need to do is actually set the template property. So here I've set the template property using a setter within a style because the template property is just another property on the control. And I've put in a control template. And it's got a border, a grid, and a series of text blocks. And with that, I can hit Control F5. Oh, one last thing. That time I didn't do it on purpose. Within weather control, I need to add a constructor. And within my constructor, it's important for me to set the default style key. And what the default style key does is it tells the Silverlight runtime which built-in style to grab. In this case, I want to use the built-in style for weather control. If instead I was deriving from button and I was creating a my button, I might not set the default style key because I would want to inherit that look from button. But again, because we care about providing a default look in this case, I'm setting the default style key. And now hitting Control F5, we should see a very exciting weather control. Woohoo. Okay, so let's go back to our slides. So that very briefly was how you build up a custom control from scratch. You derive from control, and by default, that control is lookless, which means you need to provide a built-in look for it within generic.xaml, where generic.xaml is a resource dictionary that's built into the assembly where the control was defined. And finally, you need to remember to set the default style key, because that's how we're going to look up the built-in style. Now, as you can see, when I was building up that custom control, I just kind of threw some stuff into the control template. But as we've seen, it's often the case that a designer doesn't know what exactly they need to put into the control template. And wouldn't it be great, instead of just having the designer guess, for the control developer to physically say, hey, control template, I need a thumb element inside of that template. I need a press state. I need to know what the control is going to look like when it's disabled. And then it's very easy for the control designer building that control template to hand off the thumb, the press state, the disabled state. The way we've done this in Silverlight 2 is through something called the parts and states model. It is a recommended way to build your control. It's not required by the runtime. But it does allow you to keep that defined separation between the logic and visuals while still having an explicit control contract between the designer and the developer. Like I said, this is a recommended pattern. It's not required by the runtime. It will, however, be the pattern that's supported by Blend. So if you're building up a custom control and you want it to be skinnable using Blend, we recommend that you use this pattern. So what's in the parts and states model? Well, first off, we have parts. Parts are named elements that live inside the template where the code needs to manipulate them in some way. So here you see a slider. There are 4 different parts to this slider. There's the thumb, the down repeat button, the up repeat button, and the track. And the reason why all these need to be explicit parts within the control contract is that the code logic needs to know if the user clicks on the up repeat button, I need to programmatically move that thumb along the track. And similarly, if you hit the down repeat button, I need to programmatically move that thumb along the track. So those are parts. And as a call out, not all control contracts have parts. It might be the case that a control code is fine with the visual look being exactly what it is, and it doesn't need to reach into it at all. So those are parts. We also have states. States, of course, are the way the control visually looks in a particular state. So here we have the mouse over state and the press state. And the press state has a much darker background than the mouse over state. Between states, you have transitions. So here, again, we have the mouse over state and the press state. And the transition is the visual look as it goes between those 2 states. So the animated look between the 2. And finally, also associated with states, we have this idea of state groups. State groups are sets of mutually exclusive states, and separate state groups are actually orthogonal. So what this means is, for this checkbox, for instance, it's possible for me to be in the mouse over state and the check state, but it's not possible for me to be in the mouse over state and the press state because those 2 are in the same state group. Okay. So that's at a high level the parts and states model. Let's take a look at checkbox. Okay. Opening up my snippets again and my checkbox. Okay, so in this app, I've got a stack panel and a checkbox. And then I have some buttons which will just help me toggle the visual state of this checkbox. I'm going to start off by dragging in a checkbox style. This checkbox style it targets a checkbox. It has a key checkbox style. And in it, I'm setting the template property. The control template that I'm supplying it with starts out at the root with a stack panel. And then it has a series of borders. It has a highlight border as well. It has a glow rectangle, and notice that the opacity here is 0. It has a check mark path with the opacity here also being 0, and an indeterminate rect, with, again, the opacity being 0. And that's because those latter things have an opacity of 0 because in the base state, I don't actually want them to appear. They'll only appear in certain visual states. So I'm going to set the style property to that style we just defined, and run it once to give everyone a chance to see our checkbox. So here's our checkbox. It looks pretty good, if I do say so myself. But if I mouse over it or click it, it doesn't have any interaction yet. And that's what we're going to do next. We'll add visual states to this control template. So going all the way up to the top of the control template and looking again at this stack panel, what I'm going to do is add to the root visual of my control template visual state groups. I do that by first attaching the visual state groups attached property on Visual State Manager, and then I'll define 2 visual state groups. Okay, so I've defined here 2 visual state groups. The first one's called common state, and the second one is called check states. Within our common state group, we'll start out by adding the normal state, giving it the name normal. And I don't have to do anything particular with this visual state because I want the normal state of the checkbox to look like the control template by default. With the mouse over state, though, I want something slightly different. And so within the mouse over visual state, I'm going to add a storyboard. And what the storyboard will do is literally define the way the control template will look in the visual state. So here, I want the storyboard to be kind of interesting. So I'm going to set the repeat behavior to be forever. The auto reverse to be true. And then add a double animation targeting that glow element down below. I'm going to toggle its opacity, and I'll have it go from 0 to 1 with a duration of 0.8. Okay, so that's our mouse over state, and when we get there, you'll see a nice glow because of that storyboard animation. Let's drag in a few more visual states here. So I'm going to add a pressed and a disabled state. You can see the difference, however, in these storyboards is that the duration is 0. So when I'm in the pressed state or the disabled state, I'm going to toggle here the opacity or the color of that inner border, but it's not going to be a continuous animation. It's going to be a single kind of quick change to those values. And similarly, I'll go down to my check state group and add in 3 states. Unchecked, which again is just what the control looks like by default. Check, which is toggling the opacity of the check mark. And indeterminate, which is toggling the opacity of the indeterminate rect. So running this again, I now can mouse over this. I'm getting a pulsating kind of behavior. And I can click on it, and I get an X, and go into the indeterminate state, the check state, disabled, and enabled. And I was able to do that just by dropping in some visual states into my control template, which I think is pretty sweet. One thing you might notice, though, is all of these state transitions, especially the one that doesn't have that animation, that continuous animation, happen immediately. And in order to get my checkbox to have a little bit more of a fluid feel, I want to add some visual transitions between those states. So let's do that. Going back up to my common states, and VSM visual state group dot transitions, and add a visual transition. The one property here that I'm going to set is the generated duration property. Actually make this a little bit faster. And what the generated duration on this visual transition means is that anytime I do a state change between the states within my common state group, it will take half a second. And that's something that the platform is just going to take care of for me. So if I see, I can mouse over, and this one's more subtle because it's already blinking. But if I press down here, you'll notice that it took a little bit of time for that black border to show up. And if I lift up, there's also this nice subtle animation going out of the press state. And I could do that just by adding the visual transition there, which I like. However, when I click something, I want it to happen immediately. And so when I go into the press state, I want to make it actually have a generated duration of 0. And I can do that going back into my XAML by adding in a second visual transition. This time the generated duration will be 0. But I need to say that I explicitly only want this transition to apply when I'm going into the press state. Now when I click on my checkbox, you'll see I instantaneously go into that press state. So my checkbox feels nice and responsive. But when I release it, it kind of animates back, taking that half a second. So again, I was able to do that just by adding in some visual transitions to our control template. So that's skinning a checkbox. Let's wander back. Okay. So in that checkbox demo, you saw a couple things. You saw how we use states. And we do that by attaching first Visual State Manager.Visual State Groups, I forgot the S, groups, attached property onto the root visual of the control template. I then add whatever number of visual state groups to that. And inside of that, I put all my visual states, where again, a visual state can contain a storyboard, either a repeating storyboard or an instantaneous storyboard, and that will define the look of the control in that state. We also saw transitions, where visual transitions have a generated duration where I can specify how long I want a particular state change to take. The runtime itself will take care of generating those transitions with a call out that we can really only generate transitions for doubles and points and color animations, because those are the ones that we know about. If you use an object animation, there's no good way for us to interpolate what a transition should look like, and so we leave that up to you. So those are transitions. Very quickly then, at the end, you saw that I had a default transition to start with, but then I wanted to add specific transitions for certain state changes. And the way this works is, if, for instance, I'm going from the mouse over state to the press state, the first thing that VSM looks for, Visual State Manager looks for, is a from-to transition going from the press state to the mouse over state. Then it looks for a visual transition going straight into the press state. Then a from transition going from the mouse over state. And if none of those are found, it will fall back and use the default. So again, Visual State Manager just looks for the most specific visual transition for a particular state change. Okay, so in that first demo with Visual State Manager, we saw checkbox and we saw what you do in the control template. Now I want to switch around and show you what the responsibility is with the code logic and how that code needs to call goToState. Okay, opening up my snippet manager again. Uh-oh. Okay, I'm going to run this, just make sure that we're in a reasonable state. Yep. Oh, pretend you didn't see that. I kind of gave away my kicker. I always do that. Oh, well. Okay, so the first thing that I'm going to do inside of my weather control is add in our control contract. And the way you do that is through a series of attributes that I place directly on our control. And again, this is the weather control that we started building before, and now we're going to add kind of Visual State Manager capabilities to it. So in our control contract, we use visual part attributes and template visual state attributes. So here you can see that I've got one part, it's called core, and I expect it to be a framework element. And then I have 5 different visual states. I have a normal, mouse over, and pressed within the common states. And then within my weather states, I have a sunny and partly cloudy. Now, again, just as a call out, I put this metadata on the control class because the tools will be looking for it and will be using it in order to give that good skinny experience to the designer. These metadata, these attributes are not used by the runtime at all. Okay, so let's get started. The first thing that I'm going to do in code now is add a core part. So here's just a CLR property called core part with a getter and setter. And this is where I'm going to be storing that core part that I'll grab from the control template. Next, we actually have to reach into the control template to get that part. And the way you do that is through a reversal called onApplyTemplate. Okay. OnApplyTemplate gets called every time a new template gets applied to the control. So it's within this that it's a good place for me to grab the core part. It is a framework element. And then I'll use a helper called getTemplateChild and pass it in the name of the element that I'm looking for. Okay, so we have our core part from the template. Next thing we have to do is go through our different visual states. I'll start by adding a helper method called goToState. This goToState takes in a Boolean and determines whether or not I want to use visual transitions in that state change. And then within it, I have a series of logic. I have this cascading if statement that says, if I'm pressed, please use the Visual State Manager goToState static method, pass it in the instance of this control, the name of the state that I'm going to, and whether or not I want to use transitions. And so through this cascading if statement, I'm able to go to the right state for is pressed, is mouse over, and normal. And similarly, I can do the same thing for my weather states, partly cloudy and sunny. Now the question is, where do we call this goToState helper? The first place that we'll call it is right when the template gets applied. And the reason for that is when a control appears on the page, you want to make sure that it appears in the right state. So if the checkbox is checked, you want it to appear checked. And we do this again by calling that goToState helper and passing it this time false, because we don't want it to transition when it arrives on the page. You just want it to show up checked. So calling goToState false in onApplyTemplate. The next place that we're going to call goToState is actually in our core part setter. And the reason is, in this particular control, the way I want my control to respond to mouse movements and mouse input is through listening to mouse events on the core part. So within this core part, I will drag in some code which sets up some mouse event handlers. So here you can see as long as the core part is not null, I'm adding an event handler for mouse enter, mouse leave, mouse left button down, and mouse left button up. And of course, if the template is applied more than once, I need to make sure to remove all of those things when the template changes. Okay, so I've hooked up mouse event handlers. Now I actually have to define my mouse event handlers. I'll do that with another snippet. So here, the core mouse enter method sets the logical state of the control to be is mouse over equals true, and then calls goToState. And similarly with mouse leave, mouse left button down, and mouse left button up. Okay, so far we've added goToState calls in 2 different places, in our mouse event handlers and in onApplyTemplate. There's one last place we need to add it, and that's down here in the condition dependency dependency property. And that's because when you change the condition from sunny to partly cloudy, you actually want the control to look sunny or partly cloudy. And the way I've done that is actually alter the way we registered this dependency property. I've registered here a property change callback. So on condition property changed will get called whenever the condition property gets changed. And then down here in the definition of that, static method, I turn around and call an instance variable or an instance member. And here's where I'm going to call the go-to state. So that was a little fast, but again, the upshot is in the property change notification handler, for my condition property, I need to call go-to state. And now, when I run it, here is my glorious sun. And when I mouse over the core part, which is that eclipse, I get a nice little something. And then when I click on it again, I get a pulsating kind of glow. And when I switch from sunny to partly cloudy, I get another similar animation. Of course, this demo kind of hits home with me because I'm from Southern California. And now I live in Seattle, where it's slightly less sunny. Okay, so when I was showing this demo to one of my dev leads, he said, well, wouldn't it be great if that cloud actually came in and zoomed from the left and gave it a little bit more kick? And I was like, that's a great idea. And the way we can do this, the way we can add a visual transition between sunny and partly cloudy is by adding an explicit storyboard transition. And we'll do that next. Going into generic.xaml, you'll see here I've got the built-in look for my weather control again. I've got a control template. The grid is my root visual. I've got some resources, and I've got my common state group. And down here, I have my weather state group. And you can see I've already got a default transition for all the state changes in my weather state group. But what I'm going to do here is drag in another transition. This transition is going to go from sunny to partly cloudy. And inside of it, I have a storyboard, which actually animates that cloud in from the left. And if I hit Control F5 this time, when I hit partly cloudy, that cloud now transitions in from the left because of that storyboard. And just that easily, I'm able to use the generated transitions for most of the straight transitions that I care about, but for the ones I want to snazz up, I have the ability to override and do whatever I want. Now, just to go a little bit crazy, I finished up this weather app and added a few more things. Here's sunny, here's partly cloudy, which we just saw. We also have cloudy, very sad. And, of course, rainy. So again, just the power of showing off there that it's very easy to build up a skinnable control from scratch, one. Two, to make sure you define that really well-defined control contract using the states and parts. And then the template, it's very easy for me to go around and define those visual states and also add the visual transitions that I care about. So great. So again, just a quick recap. On top of my control class, I can add the control contract using the template part and template visual state attributes. And again, a call out that those are not used by the runtime, but they are leveraged by Blend. So please remember to add them. Next, Visual State Manager does have a static public method on it called goToState. And this is the method that manages all the visual state changes within the control, and also does all the automatic transition generation and lookup. And finally, a call out that onApply template virtual is a very important virtual. It gets called whenever that control template gets changed. And it's where you want to, A, look up all the parts that you have in your control contract, and two, I think I said A before, B, B, it's where you want to do your first state change without transitions. Okay. And as a call out, you're always able to use the automatic transitions by setting that generated duration property on visual transition, but it's also possible for you to add a storyboard where you explicitly animate some of the properties on your own. And in that case, a Visual State Manager will step out and just allow you to handle the transition. Okay, so far you've seen a lot of Visual Studio, but as you know, you're going to be working, or you are, a designer. And designers, more often than not, will be in Blend. And so very quickly, I wanted to show you how we skin our weather control in Blend. I'm going to open this up in Blend very quickly. Opening up page.xaml again. This is the similar version of our weather app, so there's just 2 states here. But what I want to do is change, again, that look of the weather control by changing its template. So I'm right-clicking, and I'll go to Edit Control Parts, in parentheses Template, and I'm going to start from scratch. The first thing that I'll do is here kind of in the root of my template. In this case, I want this to be the core part of my template. So I'm going to go into the Properties bin and make sure that this grid is called Core. Next, the way this control template is going to look is I'm going to define 2 different images, a sunny image and a partly cloudy image, and transition between the 2. So we have to add 2 images. And just drag in here the first image. I'm going to call this one sunny image. And then in the source down here, grab my sunny ping. Next, I will grab one more image, drag it up here. Call this one partly cloudy image. And grab the source. And in this case, because by default I want my control to be sunny, I'm going to set the opacity to be 0. So over here on the upper left-hand corner, you'll see that I've got a bunch of different states. I've got the normal mouse over and press state, like we'd expect, and the partly cloudy and sunny states. And I go, again, blend grab those from the metadata on the control class itself. In the normal state, I'm fine with the control the way it is. In the mouse over state, I'm going to transform it so it gets a little bit bigger. So using a render transform, I'm going to increase it to 1.1 its size. Oh, you know what? Messed up there. I'm going to click on the core and then do it. So I'm not just manipulating one of the images. So there it got a little bit bigger. And in the press state, I want it to be larger as well, but also drop down a little bit so it looks like it's clicked. So there, just like that, I was able to define what I look in the normal, the mouse over state, and then the press state. In the partly cloudy state, I don't want, of course, the sun to be shining. Well, I do, but unfortunately it's not. So here I'm going to go to the partly cloudy image, and the opacity here will be set to be 100. And I'll go back to my sunny image and set that to be 0. So there's partly cloudy and sunny. I'm happy with the way it looks. One last thing, within the common states, I want these to by default take half a second. And for these weather states, I think going from the partly cloudy to sunny, I'll have it take a second. And then going from anything into the press state, I again want this to happen instantaneously. So again, I've set up my visual states by clicking on each of the states and designing the control to look like what I want. And then I was able to add generated transitions between the two by clicking on these little arrows up here and specifying a time. So I'll run this, or I build it, and then run it. And here is my control now. And I can mouse over it, I can click it, it'll bounce up, and I can go between sunny and partly cloudy. So there it is, kind of the end-to-end experience, how you're able to build up a control in code. You can alter the control template manually if you want, but then you can also use Blend, which will give this kind of very easy to understand for designer control experience. Cool. Oh. Okay. So that is, at a very high level, the Silverlight 2 control model, as well as a deeper look into the skinning support within Silverlight 2. I do want to take now a step back and look at the control models in general for Silverlight and WPF. Now, if you're familiar with Windows Presentation Foundation, you'll notice that the majority of this was very familiar, especially the core basics. So user control, custom control, style, control template, all those exist and live in both platforms. There are a few callouts, though, and we'll go into them now. In Silverlight 2, there are a few limitations on our style element. First is that style has kind of this write once behavior, which means that you're able to set the style property once, but you're not able to clear it or change it at runtime. The second is that based on styles are not supported, and that means there's no good way to add a setter to a style that already exists. That's what a based on style is. And finally, there's no application level theme support, which means that there's no way for me to define a style for a button, say, in one place, and have that style automatically get grabbed by all the buttons in my application. Now, these are all things that we really wanted to get into Silverlight 2, but for a variety of technical and timeline reasons, we weren't able to. They are, however, things that we do plan on addressing in future versions of Silverlight. The other two big questions that I usually get about the Silverlight 2 control model and WPF are, one, where's Visual State Manager on WPF? And two, where are the triggers in Silverlight? So I wanted to talk about those briefly. Okay. The first is some good news, some immediate good news, which is this week, the WPF toolkit did release a new version up on the web, and that included an assembly that allows you to use Visual State Manager on Windows Presentation Foundation today. This means you can easily port control code that you wrote with Visual State Manager on Silverlight and take it to WPF. It also means that there's an easy way for you to take skins that you built in Silverlight for, say, button or checkbox, and move those skins directly to WPF. This support, like I said, is up on the web, on the WPF toolkit today, and it will be included in the next version of WPF itself. And so very quickly, I wanted to show you how do you do that. Okay. Here is our weather control. It should look pretty familiar, although as you can tell up here, I've got window1.xaml, so we are definitely in WPF and not Silverlight. In my control, in my solution over here, you can see I also have a weather assembly, but I do not yet have the weather control in that control assembly. So dropping back, I'm going to go to the source code for the weather app that we just created. And go in here and literally grab the condition.cs, the weather.cs, and the themes directory, which has the generic.xaml, and drag it in. You'll also notice that I've added in this weather assembly a reference to the WPF toolkit. Now I can build and run, and just like that, I have my weather control running on WPF using Visual State Manager, which you have to admit was pretty easy. Okay. Next, kind of similarly, I want to show you our checkbox skin. So here's the checkbox skin that we just defined well, a little while ago. And this app, again, looks very similar. I've got my stack panels and my buttons to toggle it. The one thing, however, that I do have to add to get this to work is something called a visual state behavior. And the reason that is in WPF, a lot of the control model is based around triggers. And in Silverlight, we relied on the go-to state calls, which were in the control code itself. So there needs to be some way for me to essentially add those go-to state calls to my WPF control that I already have. And you can do this through what we call an attached behavior. So going into checkbox skin, I'm going to add a visual state behavior using the visual state behavior attached property. And because checkbox derives from toggle button, I'm going to add a toggle button behavior. And what this literally does is attach onto the control the go-to state calls. It starts listening to the mouse events in the right way, the property changes in the right way. And now when I hit Control F5, you'll see my checkbox, and I can mouse over it, I can click on it, and all of it works like you would expect, even though, again, Visual State Manager wasn't built into the checkbox control itself. So cool. Yeah, that is pretty cool. Okay, so like I said, these visual state behaviors as well as Visual State Manager is up on the web. It's in the WPF toolkit. And just a reminder that, again, the visual state behaviors need to be attached to the control that you're trying to add the VSM-enabled skin to. And the WPF toolkit does come with a list of behaviors out of the box. So you can use these with button and toggle button, list box, progress bar, text box, and toggle button, checkbox, radio button. So hopefully that will get you guys started until the full Visual State Manager comes out in the next release of WPF. And then the last question, or the last slide, is around triggers. Triggers, for those of you who are not familiar with this WPF concept, it's a way for someone in XAML to be able to react to property changes or events and initiate some action or some behavior. These were not included in Silverlight 2 for, again, a series of technical and timeline reasons, but it is something that we plan on adding in the future. So at that point, you'll see that all the control model in Silverlight and WPF really will converge very nicely. When triggers do come in line in Silverlight, we expect to add something like the following. So you'll have a trigger, it'll listen to a property or an event, and then we will have a go-to state action. And so the designer can, at that point, if they want to, initiate go-to state calls from the template itself. And that is kind of the roadmap. Okay, so hopefully you learned today a bunch about the Silverlight 2 control model, and that you saw that it's very easy to be able to use custom controls, control templates, Visual State Manager, and the parts and states model in order to build up your own button so that you can be your own button, and also be able to have that rich kind of branded experience on your websites. And finally, that in WPF and in Silverlight, we are kind of 90% there as far as having the same control model. And in the remaining places, we have a roadmap to show how those two control models will converge completely. As a call out, my blog is scorbs.com/work. I have a couple of different tutorials on Visual State Manager that if you're interested, you might want to check out. We also have several links up here. The Silverlight community site is silverlight.net. The Silverlight toolkit can be found up on Coplex, WAC Silverlight, and the WPF toolkit can be found up at Coplex, WAC WPF. As a reminder, please fill out your evaluations. They help me understand what I'm doing right and those few million things that I'm doing wrong. So always good to know. And with that, thank you very much, and I will open it up for Q&A. And I think there are some microphones if you would like to ask any questions.
Hello, I have a question. This is all great, but what about support for native .NET Windows forms? The host control is pretty overbearing right now. It doesn't allow you to animate WPF controls over top. So what's the plan for native forms support?
Sorry, you're asking about Windows Form support, native app support in WPF or in Silverlight?
In Silverlight or WPF?
Okay, I don't know of any plans at the moment to support native code running from an application inside of Silverlight. There's a lot of, it's both a lot of work and also a lot of security concerns because we don't allow trusted code running in Silverlight. Unfortunately, I don't know exactly what the plans are for WPF right now. If you go over to the Expo Lounge, there are a lot more WPF experts who can help you out with that. Thanks.
I have a question about, over here.
Thanks.
About Blend. Can you
Okay.
use, I know you can now use the Visual State Manager for WPF. Can you use Blend's State Manager panel?
Right, so I unfortunately don't have a key with me, but there is a reg key that you can flip and for Blend, at which point you'll get WPF, the Visual State Manager support on WPF. in Blend.
You make that available online
Yes,
or on your
as soon
blog?
as I find it out.
Okay, cool. Thanks.
Thanks.
I have a question. I saw you right here.
Thank you.
I saw you running Blend 2.5. After you installed the Silverlight 2.0, that didn't seem to work on my machine. So is 2.5 the same as the latest version of the service pack for Blend 2.0?
Yeah. So whatever the most recent version of Blend that's out on the web, released for Silverlight 2, that's what I'm running.
Yeah, but my point is that there was a service pack for Blend, and then there's also the 2.5 version. So which one should we use?
So I have to admit that I forgot all the numbering versions that Blend went to. Okay, so it's 2.0 with a service pack.
Okay.
So I just know it is the most recent version of Blend, sorry.
I have a question for you, Karen, over here.
Thank you. I feel like the last little kid.
Yeah, I've made some control templates where I could modify, say, a list box where I've downloaded an example, say one of yours or whatever. And that worked okay, but if I went to create, say, modified the thumb on a list box just from scratch, I found it difficult to find that bulk of code that you use to be able to drill down to change just an individual element within that control template. How do you do that?
So the way control template works is that you are defining the look for the entire look for a control. So it's not possible to just change one part of the control template. You have to actually replace the entire control template. That being said, if you go into Blend, I chose, edit template, create empty. You can also choose edit a copy of this template, at which point they grab the template for you and you can tweak it really easily without having to worry about drilling it in.
I'll have to get the latest version of Blend to do that. All mine were the betas, but I was looking also to just copy the XAML from a known location, if that was possible. Is there a way that I could, so in Visual Studio, I could just copy that XAML code and then edit it directly?
Not through Visual Studio in some automated wizard kind of way. We do publish all the control templates in the SDK, so you can grab it from there.
Yeah, so I just find those and then grab it. Thanks.